What's going on, YouTube? We're back for episode 2 of how to make a video game on your computer. So in the last episode, we did some stuff. What did we do? We started working on the map, I think, and we added this character model, I think, maybe, and then did we do some modeling? I'm not really sure, but I did some mining off camera. Oh, that's not good. I did some mining off camera, and the game is kind of I added a few more things. Let's see. So we kind of have this. We have these two characters. We have Laura and Lars. Oh, it's not supposed to be Laura. I think I was really sleepy when I made this. It's supposed to say Lyra. Lyra.
Whose name's Lyra?
Lyra. I read you a book one time to sleep, and the main character's name was Lyra.
Her name is Laura is a more accessible name
than Lyra.
Yeah,
is Lyra
I've
not
never
a name?
met anyone named
Lyra.
but I've met people named Laura.
Lyra Aldra den stycket. Och det Lyra för. Wait, I have the VPN on. Okay. Lyra name. It's a feminine name. It's very important. It's famous. Wait, it's famous. It's famous. Okay, let's keep Lyra. Oh, wait, 10% plug in the power cord. Should I go over here, over there? What do you think?
I don't know.
Okay, see, basically he's saying here. So, excuse me for 1 second, because unfortunately my assistant is unwilling to plug in my computer.
You never asked me to.
Well, can you plug in my computer?
Yeah.
Thank you. Okay, so when you're making a game developing, it's always important to have people you can trust as your assistant. Thank you. Love you. It's also important to stay hydrated. So
And kill yourself.
You're gonna get me demonetized. You have to say unalive yourself.
To dead yourself.
He committed oof. He committed self-oofing. Oh my gosh, wait, are you gonna put a laser on my chest? Oh. Don't make me go blind, please. Well, this looks like this would be my last video. Okay, stop. I'm scared.
Sorry.
Okay. Alright, well, so we have YouTube stuff to do, so let's pay attention. Are you going? Oh, yeah, he left his phone. He would never do that. Okay. Is there a way I can, zoom this in? Wait, but I probably shouldn't do that. Okay, wait. Okay, I didn't even talk about the gameplay. Okay, so in episode 1, I think we got people, these guys to walk around, this guy or girl to walk around. And then I did some work off camera, and I added this, I made this little cone thing, and that's gonna be his vision cone. This is our enemy. And whenever you're in the enemy's cone of vision, the scrutiny bar goes up, right? The longer that you are, and then it will go down if you stay out of it. And then if you swap while you're in it, that'll be a big whoa, what just happened kind of deal, right? And also there's these little charges now. Lyra and Lars have different charges, and if you reach the end, as you will see in approximately 20 seconds, or actually approximately 15 seconds, then something crazy will happen, which is a sort of a swap without you really doing it. It's watch this. 3, 2, 1, as you can see down here. Boom. And then, our scrutiny comes out. They have their own energies, right? So that could be cool. I'm planning to do something cool about that. The architecture so far is going good. I'm really, it's not tangled. Well, it's not that tangled. A lot of signal stuff. We have a big signal bus. I'm really using a lot of these export things, which is in Godot. You can connect nodes or anything to other things in the editor. Here, for example, I click, for example, girl profile. I click just click this. So I don't have to assign like an absolute path, and if this node moves, like it'll be tracked. Are you playing with the kitties? Okay. And did you see Bimo poop that invisible poop?
Yeah.
Okay, wait. And yeah. So that's to catch you up. How much has it been? Dang, I'm already out of the view time retention. Like, oh my gosh. Now nobody's viewing it anymore. Okay, that's fine though. We have to try to make this a fast video. So what we're gonna do is we're going to work today on, I think, pathfinding, or not, well yeah, maybe pathfinding. Okay, so we want these enemies to like kind of walk around. That's my mango. Yeah, my mango. So we're going to make like a navigation region. So navigation mesh. So navigate. So wait, maybe change or remove in future versions. No idea why. So traversable 3D region based on navigation mesh. The navigation. Did I not add it? Navigation region 3D. Okay. So we're gonna make a new navigation mesh, and then we're gonna say bake it. And are we actually? Do I have like view navigation mesh turned off or something? I don't know. Does the map have to be inside the navigation region? Be embarrassing. It looks like it does. Nav region for short, right? Okay, I think that was like a pathing thing. Okay, so now we have like these. This makes like an A star, or this like makes a mesh that like an agent can use A star on. And so with this enemy, let's go into the enemy. Let's make something called like the let's make a node. I like to put all these like managing thingies in nodes, and then the actual like enemy itself does not have anything in it really like substantial. So that's kind of cool. Let's make this node called like a path. Find pathing manager, or like for the character we called it character movement. We could call this one enemy pathing, maybe. And it also keeps defaulting inside the character record because I kind of just copy pasted it from the thing, which is really annoying. Oh, are you getting ready to go? Okay. So sadly my boyfriend will be dying. Oh, hopefully not. Okay. So inside enemy pathing, or actually maybe we should change the type of this to be the pathfinding. Like there's a thing called like an agent navigation agent 3D. So yeah, this is basically a node that wraps around some of the navigation server functionality. Yeah. Is there a way we can get get random point on? I remember this was like a highly requested feature at some point, but don't worry, dude. Figured it out. Call and get vertices on the nav mesh gets me a bunch of positions I can get the dudes to teleport to. Wow. I think this is the function. I think I was subscribed to this, and it ended up being swag or something. Like, let's see. Random point queries. Alright. How do we do this? Map get random point. Well, let's see if this is even supported. Navigation map get random point on nav server. They're weighted by their surface area, but we don't really care about that immediately. Let's see. This is our navigation server. So go to random point. Well, it kind of seems like a cop-out to have them randomly walk around, but just for now, let's have that work. Navigation server 3D dot map get random point. We have a map versus an RID. I don't know, how do we get an RID? What is that? I guess a resource identifier. Self.get map wait, what is that? Get navigation map returns an RID. Bar map ID. You going? He didn't respond. Gosh, that's so sad. Well, I'm sure he did. I just didn't hear him. Okay, wait. Yeah, okay, map RID, beginning with the random point, navigation layers uniformly. Looks like these are all required because they just are. RID, and the navigations layer, I think is just one, so we can really just say this is one, right? Yeah. Zero value one. And then we have what's it called? Uniformly. I don't really care about self. That, like, what is it, like target position equals point. Okay, and then we should maybe look at the documentation for the navigation agent 3D. Let's see here. So, after setting the next path must be used every physics frame. Get next path position. Every physics frame. Okay, so well, let's see. Process physics process. Why are you gonna not like paste in that? I feel like I totally copied that. Whatever. Get next path position. Next pause equals this. So then we're going to basically try to get a reference to the character enemy, which is going to be an enemy. Should inherit from character bot 3D. We're using export here because I have decided not to use get parent like at all in this project because it's bad, right? Like whenever you use get parent, it kind of makes it so it just like creates like the opportunity for some terrible spaghetti. I don't know how I feel about having my hair down, honestly, right now. It's kind of sketchy. Whatever, I'm sure it'll get better. Jamie said I should probably keep it down. Or, well, he said it was fine down. That's not the same. It's very important. Anyway, so we have the thing, we have like what, move and slide, I think it is. Which just does perfectly what you just say, like enemy dot velocity dot. Let's just leave y and x alone and just say, you know, this equals. Let's get the direction, obviously, to our, you know, where we want to go. So we're gonna get the enemy dot position dot direction to normalize. Oh my goodness, it does it for me. That's so beautiful. Next position. This is just gonna be direction dot x, and then we're gonna do something else for the z. We're gonna leave y alone because we don't like it to be floating. You know what I mean? Yeah. Let's just let's see how that ends up working. Okay, so we clearly something is happening here. Alright. Pretty great. Alright, yeah. Cool. If the enemy position distance to the net. Wait a minute, is there like a that is negation agent? Is there like a waypoint reached? Okay. Point reached. Connect. Apparently it has something called details. So whenever we reach a waypoint, waypoint or we want target reach. We don't want waypoint reached. Waypoint, I guess, is like a point on the path. Okay, I wish I didn't keep that thing up there. Sorry, I'm using the Z editor. I think I mentioned that last time. So if we reach the target, then we are also going to go to random point. Alright. Then, what was I thinking? Yeah, we need to do a rotation thing, kind of like the character does. So in the character, we have this little bit of code that's like our rotation for our Y is actually going to be our movement direction, like that, which I thought was pretty cool. I think this is like pretty genius. So we would say like if enemy dot let's say if enemy dot position dot distance to the if the distance to the next pause, this is the next position, is like greater than like 0.1, then like 0.05, then do this and do all this stuff. And then with movement direction, we just say movement dir is actually just going to be direction. You can also put this in there. And we have this thing called character model rotation, but that's just going to be the enemy because, oh, that is very interesting. We do the character model instead of, well, let's take a look here. So why are we rotating the character model instead of the whole character? That's really interesting. I have no idea. Let's try just doing the character instead of the character model. Just see, I mean, if that works, right? Oh, the camera. That's why. Okay, so the character holds the camera, which obviously we don't want to be rotating. So this makes sense. Okay, what are you doing? You're just kind of wandering around. Not very interesting. So the velocity here in enemy pathing is, it has the velocity, it's the direction. It's actually direction. So we'll play this by like 3.0 or something. Here's what I understand. The enemy rotation on the y-axis should be like this. I'm having a hard time believing that this just is not working. Like nothing is happening here. So we say character move the slide, and then we do all that stuff. Maybe that's what we should be doing here. What is this terminal that keeps getting in my way? So we have that. We have that. Okay. Everything else is pretty important. We'll keep that. Okay. So clearly, target reach does not Navigation finished. So if we say navigation finished instead of that. Does this require? No, it doesn't. So we're gonna change our function for the third time. So that's okay. So I guess in this scenario that it isn't reachable, which it isn't, it's gonna be doing that. Okay, what is going on here? So, okay. It's really scary what it's doing here. It's like, okay. Alright. I don't know what to make of that. It's kind of frightening. Direction Y. There's a direction Y. Is direction that Z is supposed to be used here. Well, that explains it. Let's interpolate that a bit more. Let's say we have this thing here. We say 0.3 is fine. Let's say that that's not fine. Let's do 0.1. We don't really care as much. It doesn't need to be as responsive, if that makes sense. Like the okay, can we make our agent like a bit wider? I'm seeing that as an issue because we keep running like into things. Another thing, agent width. Agent width. Corridor funnel. Path. Let's simplify the path. Okay. The path start. Simplify epsilon. World units. As we said the 1, it's gonna freaking happen. Where are you going? Interesting. Okay, so it definitely does not feel human yet, but it is working. Like, it's very clearly working. So that's interesting. Can we make that work? Let's see. Navigation agent radius. I'm changing navigation agent's radius. We don't have that, do we? Oh, is that an avoidance? Avoidance of the radius agent. Does not affect normal pathfinding. Oh, I have to bake the mesh with a different radius. Okay. That is interesting. Okay. A different radius. What do these do? Watershed. Generally the best choice if you pre-compute the navigation mesh. Tone. Okay, so it looks like different stuff, like if you're generating live or not. Okay, cell size. Agents. So let's say 0.75 is the width of our agent, and then we can recompute this. Okay, so they can't currently get in there, which is bad. It's like 0.6 maybe. And they should be able to get in there like a little bit. But they just get so freaking close to this edge, like it makes me uncomfortable, right? I don't know. Yeah, they need to be able to get in there, right? But you know what I mean? Cell size of the navigation map. Wait, what is the navigation map? Must match the cell size on the navigation map. Larger cell size. 0.75. Still does not really fix the problem. Okay, so let's keep that there. And then I wish, like, border size. Border. Hi, Khaleesi. Meow. This is Khaleesi. Ouch. Khaleesi, I'm trying to work. You can't be here right now. I'm sorry. Come on. You can't, just not right now, okay? Yeah, just not right now. Because I gotta work on this. I'm sorry. Okay. Let's take a look here. Polygons. Details. Ample distance. I would like to... Bah. Whatever. I think that's just what we have to... I think we might have to live with that for now. It's printing out a lot of information. What is it printing from? Target angle. That's okay. Is that all really? I mean, for now, it's really all we need to do. Okay, that's bad, right? Did we change something weird on the pathing? We did simplify the path. Maybe that'll... I don't know. Okay, we're just gonna deal with that for now. As weird as it is, I think this is the best. Maybe not. Maybe we do want to actually change the radius to be about like 1 meter. Right? Because then it's just not doing like stupid shit. It thinks that like it can get in there somehow. It can't. Like you... Why are you doing that? Like, is it like the simplification is that... Is it just freaking making you go around a corner? I'm so confused. Let's see. Turn off simplify path. Okay. Get rid of it. Okay. I want to see you go around a corner. Okay. This works. Okay. You are just so freaking jittery. Okay, like you're a little too fast even then. So let's maybe set you down to 0.02. Something like that. Anything like that, right? Okay, well now he's just freaking moonwalking. You go from... Okay, well that's obviously bad. How about this? How about this? Maybe it needs to be based on the like the actual amount you're turning. Okay, and then I want to make this cone a little wider. This cone generation algorithm thing, it's really bad. Okay, cone width, it's just really bad. So like, it's really bad. It's obviously like the meshes is inverted or something, and it's just like not freaking good. Okay. So I knew it was bad, but that's obviously like a super problem now. Because yeah, okay. I'll have to fix that maybe off camera. But wait, can we calculate a specific height So if we have, like from a degree, I wonder, like a width from a degree. So if we have a triangle like this, we have a triangle like this, we want to know the length of this based on this angle. We need to, and we have this right here, we need to something like what? This is opposite, this is adjacent, some old hippie. So we're trying to get some equals old hippie. So if we can get sine of, like instead of cone width, we say cone angle. So this is, you know, like, it's like pi over, do they have dig to rad? They do. Let's do 45 degrees. Okay, that sounds good. Then we can say cone height is actually sine of cone angle multiplied by cone height, and it's obviously not cone height, it's cone width. Now, is the compiler smart enough to recognize that as a constant expression? Oh my swag, it is. And it looks like it worked. Cool. So if I say, but that's really a multiple, right? Because there's two of them. So arguably, I would say, it's 2.0, and then it's like an actual field of view 45 degrees, something like this, right? I'm like, okay, that's pretty good. Okay, I'm enjoying that, and then we can, you know, change. And then I eventually want to make it so like you can, like there's like an audio sort of function. Or maybe add a bunch of these little guys. But for now I think that's it. So thank you everybody for watching episode 2 of how to make a video game, and I'll see you next time. Goodbye.